Hey, Algebra 1. So yesterday we had a pretty easy day with the diamond puzzles there, and those were getting us ready to think about how to factor trinomials. So here is just some notes that I wanted you to have, and then also attached is your assignment, and we will be doing these two examples here in just a moment. First, we need to get some stuff out of the way, like vocabulary. Our trinomials, which is an expression with three terms, those need to be in standard form. And those are going to be standard form for a quadratic. So all of the different linear model, or I guess functional models, linear equations, quadratics with the parabolas, the stuff that you're going to get to into Algebra 2, the cubic functions and everything else, they all have standard forms. And so the standard form for a quadratic is ax squared plus bx plus c. And so that's our squared term, our x term, and our constant term. This is what we call descending order, but you don't need to know that today. If the middle term is missing, such as if we have x squared minus 49, then that b value up here, that b is just going to be 0. So we could technically write this as x squared plus 0x minus 49, but that's really, really unconventional, and nobody does that. The SAT doesn't do that. The iLearn doesn't do that. Nobody writes it that way because we don't use zeros like that. This is, however, very helpful whenever we're starting to think about how to factor. So here we go. Yesterday, we did the baseball diamonds. We found the two numbers, the two factors that multiply to be the top number in the diamond, and then added up to be the bottom. Obviously here we don't have any numbers yet, but we'll get there in a second. So today we're going to make our own diamonds using numbers from trinomials, and then we're going to use those to factor the trinomial. So here we go. This is actually a Google drawing, and so maybe I'll be able to edit it. There we go. Got this. My phone's going off, but that's okay. So we decided yesterday that it was the two numbers that multiply to be the top number. That number is going to be text box. There it is. The C term. That's always going to be the C term. Two numbers that multiply to be the C term. In which case, or in this case, sorry, there you go. In this case, C is negative 90, not just 90, negative 90. So what two numbers multiply to be negative 90 and add up to be something? Okay, so we multiply the two numbers to get the C term. We add the two numbers to get the B term. And here you're saying, oh, the B term's M. That's not a number. We can't do anything with that. So no, the B term is not M. The B is that invisible 1, so the coefficient of M. And let me get my text box out again. So we're going to have two numbers that add up to be B. And in this case, that is positive, see the plus here, 1, because there's no other coefficient of M. So what two numbers, then, this is our question, this is our puzzle. And we'll do a couple more of these examples, so if you're not quite with me yet, that's okay. We'll get there. What two numbers multiply to be negative 90 and add up to be 1? Okay, if you need more time, whatever, you can pause the video. I'm going to go ahead and tell you. It is 10 and negative 9. There we go. 10 minus 9 is positive 1, and 10 times negative 9 is negative 90. Now, this is not my final answer. These need to be factored. So what we do then is we take those two numbers and we put them in parentheses, and we're going to make two binomials that multiply together to be this. So that's going to be m plus 10 and m minus 9. So here, if we went n times m, we would get m squared. M times negative 9 is negative 9m. M times positive 10 is positive 10m. So 10m minus 9m is 1m. And 10 times negative 9 is negative 90. So these are the two factors of this quadratic or trinomial expression. And that's what we do. We take our variable, same variable in each one of these binomials, there will be two. And then we take our numbers from the X or from the diamond puzzle or whatever you want to call it, and we put that in the same binomial parentheses. Okay, so that's our final answer right here. The factored version of this is m plus 10 times m minus 9. And the reason that we factor is because you can't go through and divide this by, let's say, m minus 9 unless you have it in factored form to see what binomials multiplied to be this. And we are going to see that here very soon. All right, now the other way to do this. So obviously here, doing the X on the computer is a very challenging and time-consuming thing. This would be a lot better served in a classroom where we have our dry erase tables and where we have the smartboard to project this on. But what we're going to do here, these are the examples. We're going to find two numbers that multiply. Remember, we multiply the C term and add to be the B term. Okay, so in this one, the C term is the third, the single number, the constant. So what two numbers multiply to be 8 and add to be negative 6? Again, that negative on the 6. So two numbers that multiply to be 8 and add to negative 6. Negative 4, negative 2. Now, this is not our answer. Our factored form is our answer. So this would be y minus 4 times y minus 2. That is our answer. We could FOIL this back out or distributed it back out. Y times y is y squared, and so on and so on and so on and so on and so on. But when we FOIL this out, we should get the exact same thing that we started with, and that's how we know that we did it right. So this is a more computer-friendly version of the same process. So here, what two numbers multiply to be negative 48 and add to be negative 8? And those numbers are, got it, negative 12 and 4. So my factored form, my final answer is going to be y minus 12 times y minus, or I'm sorry, not minus, plus 4. So here, negative 12 times positive 4 is negative 48, and negative 12 plus 4 is still negative 8. And so that once we do enough of these, you can see the relationship between factoring and multiplying these, and you can see how you can do a shortcut. Because like yesterday or the day before, whenever we were multiplying binomials, at this point in my life, I've done probably literally a million of these. And I was able to just look ahead and be like, yeah, obviously this is going to multiply to be, well, I mean, this one in particular, x, oh, I used y's, silly me, x squared minus 8x plus, I'm sorry, not plus, minus 48. So anyway, that's what we're aiming for, because this doesn't go away. This comes back to Algebra 2, and then they actually bridge more off of this, and then you got 3 and 4 factors, and then you're dividing things and whatever. This is a very fundamental skill, and this is what is so important about Algebra 1. Okay, let me see how much time I have. All right, I'm going to make the, oh, guess what? I'm all out of examples. So this is your assignment. There are 7 problems here, and the longest thing that's going to take you is actually typing it out, which you saw does not take very long at all. We're not even using the x's, so it's like whatever. Find 2 numbers that multiply. I'm going to leave this part right here so you remember multiplies to C, adds up to B. So multiplies to be this number, adds up to be that one. What are those numbers, and then what is your factored form? So please watch out and don't get caught in the same trap that I was in, where you're not using the right letter. All right, any of these that need to be a specific watch out? Yes. Number 7. Again, we have that invisible 1 coefficient, and it's not just a 1, guys. Not on this one. It's a negative 1. So that whole minus W, that's a negative 1W. So just watch out for that. Keep your signs in mind, and that's pretty much all I got. If you have any questions, please make sure that you let me know, because right now, with what we're doing, if you're keeping up and doing the things, your grades are going to be fine. But what is the most important thing right now, school-wise, is that, or for this class specifically, because I can't speak to anybody else's class. For this class specifically, we need to have the basic of factoring down. This is going to come back in Algebra 2. You may see it again in geometry. It's been a long time since I've seen the geometry book, and I'm not entirely sure where we're using this, but it's definitely going to come back in Algebra 2, and that is something that you want to have under your belt, at least a vague memory of. So please make sure that you do these. If you have any questions, let me know, and we'll work with you. All right, you guys have a great rest of the day, and we'll see you tomorrow.